Hello student, welcome all of you in lecture number 6 for the B.Sc.SY student semester 3rd and paper is real analysis. In previous lecture we have already discussed about what is meant by supremum of set and what is meant by infimum of set. So we discussed it with some illustrative examples. Now I am going to define it by some special properties. So we observe that supremum of set, yes, supremum of set, yes. Suppose yes be the any set. Suppose yes be the any set. It has any element, then supremum of the set, supremum of set may or may not exist, may or may not exist. It may or may not belong to, yes, see here, it may or may not exist and may or may not belong to set. This is about the may or may not belong to set. So whatever the supremum of the set, suppose yes be the any set, then supremum of set may or may not belonging to, or may or may not exist, or may not belonging to the set, yes. Actually, what is the supremum? What is the supremum? So supremum, I say it is M, is the smallest upper bound of S, is smallest upper bound, smallest upper bound of set S, and may be described with the two properties. We describe it by the two property, and first property is M is the upper bound of S. M is the upper bound of S. So that is X less or equal to capital M for all the X belonging to S. So if this capital M is the upper bound of S, so what is in the upper bound? Upper bound means all other elements of the S must be less than or equal to capital M. So this condition must be satisfied by supremum. Now second point is no number less than M. No number, I write it, no number less than capital M can be upper bound of S. Can be upper bound of S. No number which is less than M can be the upper bound of S. Meaning is that M is least upper bound. No other upper bound less than M is present there. So therefore, that is for any positive number for any positive number epsilon. We take any positive number epsilon. So this epsilon is the positive number which is very less, but it is the positive number. That means 0 point something number. So however small, no problem. However small, there exists a number y belong to S such that this y must be greater than m minus epsilon. So if m is the supremum, so if it is supremum, then m can be the upper bound of S, and for the any positive number epsilon, however small, there exists a number y belonging to S such that y must be greater than m minus epsilon. That means if set S is, we have already discussed this sum, set S is this. So if we have to make the set of upper bound of S, so set of upper bound of S is like this: 5, 6, 7, 8, 9 and so on. So this is the least upper bound. These all are the upper bound of S. These all numbers are upper bound of S. But what we can say about the 5? So all element 1, 2, 3, 4 less than 5. And so 5 is least upper bound. 5 is least upper bound. So if we take the epsilon is equal to 0.0.1 and 5 minus 0.0.01, so then whatever the number, this number must be less than 5, that is capital M. So if we subtract any small epsilon from the M, then y must be greater than, and that belong to S. That means this example is not proper. So if we take the set 1 to 5, this close interval, and if we subtract any epsilon, whatever this is the small, however this is the small, subtract, then we get suppose 4 point something number, and this 4 point something number is present there and it is the greater than 5. So it may be seen that a set cannot have more than one supremum. So what is the supremum? These are the definition. This is the definition of the supremum. One thing is that M is upper bound of the S. M is upper bound of the S and all the x are less or equal to M for all the x belonging to S. Second point is that no number less than M can be upper bound of S. For any positive number epsilon, however small, there exists a number y belonging to S such that y must be greater than M minus epsilon. Now we discuss one thing, that set cannot have more than one supremum. A set cannot have more than one supremum. That means every set has only one supremum, no other supremum. Suppose we have to prove this. Prove that a set cannot have more than one supremum. So if we have to show that any set has, meaning is that has unique supremum. Suppose we try m and m dash, these both are supremum. M and m dash, these both are supremum of some set S. So if m and m dash are supremum, then m and m dash are upper bound, no doubt. These are upper bound. Of yes, upper bounds of yes. Here we assume that m and m dash both are different. So if m and m dash both are different and m dash are the upper bound of yes, then we can consider m is least upper bound and m dash is an upper bound, because both are different, both are distinct. So we can conclude this m is less or equal to m dash, because m dash both are upper bound, both are upper bound. So either m or m dash must be greater. So we choose here m is least upper bound, then m dash automatically only upper bound. So m least upper bound, m dash upper bound. This is first situation. And in second condition, we can assume that m dash is least upper bound and m is an upper bound. So in this case, m dash is least upper bound. So this is less or equal to m. This is second condition. So in the first point, m is less or equal to m dash, and in the second point, m dash is less or equal to m dash. So this situation indicate that, this inequality indicate that m is equal to m dash. So our contradiction is that set S has two suprema, m and m dash. It is false, and therefore every set has only one supremum. So now this definition we can revise for infimum. Now I hope you should study, or you should guess what is meant by the infimum of the set, and what its definition, or what is the descriptions, which property satisfied by the. So here replace this capital M by small m, smallest upper bound, so it is least, greatest lower bound, replace something, greatest lower bound of yes. There is a capital M, so write here small m is the lower bound of S, lower bound of S. If lower bound of S, then there is a this m less or equal to x for all the x belongings to S. No number less than, so replace this less than by greater than, small m. We are changing for the infimum. All these changing for the infimum. Can be lower bound of the S if for the any epsilon positive number greater than positive number epsilon, however small, there exists a number. We take here Z, and this Z such that this Z is less than small m plus epsilon. And all the property we just take vice versa condition, and we can understand all things of the supremum is the same allow for infimum. So student, this is the mathematical definitions of supremum and infimum. So I hope you should understand all these things. You can read it and revise it. In next lecture we will discuss one completeness property. Thank you very much.